So hi everybody, I am Florian and I'm a software developer. If you want to learn more about me, you can check out my website. Today I want to talk to you about hobby projects and about home-cooked software. I first picked up the term home-cooked software through Hacker News. I found just a random blog post which was about, it has the title, "An app can be a home-cooked meal." And this post tells the story of a developer who maintains a mobile application, just a tiny messaging application for his family. So the application has 4 users, next to no features, and since he did the first release, he pretty much never had to update it. And at the end of the article, he tries to make a bridge between cooking and software development in the sense that if you want to learn how to cook, there's a difference if you want to do it so you can cook at home, or you want to be a professional chef in a work environment. And what I love about this talk or this blog post was that it basically reduces down our craft software development to the bare essentials. It's about you, your code, and some need you want to fulfill. So there's no Confluence documentation, no Jira tickets, burn down charts, story points, t-shirt size estimates, and all the, let's go with fantastic tools and practices we engage in a work environment. And what I took away from that blog post as well was that if you're a professional developer and you want to do some coding on your own, it's pretty fine to do things a little bit different and just to be foolish and do things in a way where you're not constrained by time or by budget, basically. And this is what I do. So I developed Chunkyard, which is a backup tool. It's a console application written in C#. And when I first started the project, it was pretty much about, well, giving myself a fix in the sense of I wanted to have a tool which works the way I want it to. But over time, the feature set became pretty much stable, and I started to use the project more as some sort of a platform to just learn and experiment at my own pace. And this presentation is just a few stories around that. Now, before I talk about these stories, let's take a step back. So a couple of years ago, I had pretty simple backup scripts. On Linux, I was using rsync, and on Windows, I had robocopy. And those scripts pretty much worked fine. I plugged in my external hard drives, I ran the script, and they would just take whatever files I had in my script and take the current snapshot to the hard drive, which meant it was just a mirror of that. And it also meant that I only had the latest version, the current one, on those disks. And then, again through Hacker News, I found Restic. And Restic tries to be a cross-platform backup tool. It's written in Go, and it has a pretty amazing set of features. It's not the only tool out there. We will talk about this in a second. But, well, I'm just going to tell you a few of the features. Those are not all of them, but just so you get an idea. Now, first and foremost, everything that you backup with Restic is encrypted, which is just neat because I didn't just have that. The second cool thing is this concept of a repository. So in Restic, a repository is pretty much like a container, and the container can contain several backups. Now this can be from different machines, as well as a version history for a particular machine. So if you run the command on a single machine, maybe like once a week, you get a snapshot for each one of those, and then you can also check out previous backups you had there. And the clever thing about this repository is that it tries to deduplicate data as much as possible. Because if you would try to do that with, well, the naive approach of just copying everything over, you would have the same data over and over again. Now, how does that work? Well, deduplication on its own is like maybe a whole conference talk, so I will be very brief here and really vague. So the secret sauce basically is content-addressable storage. It's the same technology that also Git uses, for example, and well, that's the bedrock. And the second thing, content-defined chunking, is basically just an optimization on top of that to work better with large files. And the last cool feature I want to highlight here is that Restic can help you detect broken hardware, or in general, it gives you a check or a verification method. Now, when it comes to backups, there are, well, at least two universal truths. The first one is that one backup is actually no backup. And you always have to make sure to have at least two copies in at least two different locations. And the second universal truth is that performing backups, or the operation of doing a backup, this one usually succeeds and is fine. But what usually people start to encounter problems is when they try to restore from that backup. Now, if you don't believe me, just use your favorite search engine and search for restore fails. You will find companies like GitLab and a bunch of others as well. So just having a backups, if you have backups, that's cool. If you check that your backups work and you can restore data, it's even better. And so because of that feature set, I was intrigued. Restic sounded amazing and I wanted to try it. So I cobbled together a new script and I tested my old scripts and the new ones just in parallel. And for the most part, things were pretty much fine. It's an amazing tool. But every time I ran a command and it would output me a message or a warning that I didn't understand, I had this nagging thought. I don't understand the tool. Should I really use it? And that is really ignorant, right? I have no idea how a modern computer really works. I had courses about how CPUs work in university, yes. But do I know how a CPU really works? How firmware works? How file systems works and all the bugs that they have? So overall, me thinking I don't understand Restic, should I use the tool? A stupid thought. But then again, I wouldn't be standing here if things were just fine. So thank you, past me. And so I started to wonder, how hard can this be? It's just encryption, content-defined chunking, content-addressable storage, metadata tracking. You combine those, easy peasy, you have your own tool. And Restic even makes this easy because the documentation pretty much explains you all the concepts. And by reading that documentation, I also found out that I don't need most of the stuff or some of the features that it has. So if I just build my tiny thing with the things I want, I am fine. And so the project started pretty much 5 years ago, and now it has over 1,500 commits. That number isn't here to entertain anybody, but it should just highlight, I told you the feature set is pretty stable, that I use the project just to have fun, to try things. I do something, maybe I revert it, I do something else. So it's just me playing around with the tool. And if it isn't obvious by now, please don't use my tool. Use some of the real things like Restic or this repository here, which contains a bunch of other tools. They are much better. But the great thing about a hobby project like this is you're not constrained by time or by money. So you can do things which might not be feasible in the work environment, like being foolish, curious, sometimes bold, or it's also fine if you fall on your nose and you realize that you have no idea what you're doing. So the first story I have here is that when I started my career as a C# developer, when I made the transition from Java. At that time, Visual Studio was pretty much the only tool out there. There was next to no command line options, or those that existed, they were pretty clunky. But over time, the language itself evolved, and it's now pretty easy to also work on Linux, because now we have a command line tool, the .NET command line tool, which works the same way across basically all the operating systems. And so essentially, all you need to do C# development nowadays is using an editor and a terminal. But that is not the most productive thing, right? An IDE gives you all these things like auto-completion, you have a debugger, or error highlighting. So me giving up on those things is unproductive or not reasonable, but it's fun. And so I did it. Now I am fully aware of that there are things out there like Visual Studio Code or the language server protocol, which makes it possible to configure your editor to be kind of like an IDE, but I chose not to. And while it felt really unproductive at first, I started to appreciate a few things. First of all, I became better with the language because I didn't rely on auto-completion. I knew my code base a little bit better. You could argue that that's not important with all the AI stuff we have right now, but I started the project 5 years ago. That wasn't that big of a hype at that time. And I also learned to appreciate the online documentation, at least for C# much more. Because usually when you're in your IDE, you get auto-completion and you get the messages for how the function works. But usually the documentation itself contains much more, which are some preconditions, what are some special cases, what assumptions does the function have, and also what are interesting other things related to this one. So me giving up on an IDE started as a pretty unproductive thing, but over time I really started to appreciate what I learned by that. Now, when it comes to learning, I have the problem that I can't learn for the sake of learning. So if I try to do that, I usually can't retain information. And even if people try to push something on me, if I have no interest, it's pretty much gone. It's a lost cause with me. So when I want to learn something, I need to have a goal or some task I want to fulfill, and then I learn just enough to get what I want. And when I started out the project, I pretty much didn't know about some of the concepts. Yes, I knew about encryption in theory because of university, but how does encryption work in this year in C#? What are the current standards? How to use the libraries, and what gotchas are out there. Also, I didn't knew about the deduplication techniques, and so I also had to dig into those. And what was interesting to me is that I found out that these two things, encryption and deduplication, are basically opposing forces. Well, why is that? Well, what's the goal of deduplication? You try to take the same thing and reduce it down to just one thing. But on the other hand, encryption tries to make the same thing look different all the time. So if you take some piece of content and you run it through an encryption function, what's the output? Well, of course, encrypted content, which should look like randomized data to most people. But if you do the same thing again, the second time, the data should also look totally different to the first one. So there's no relation between these two files, at least from an encryption point of view. And so this means if you combine encryption and deduplication, you're on this spectrum. If you just mush them together in the most naive way, you have a system that is encrypted and doesn't do any deduplication. And if you go the other way and you start thinking, you know what, I can just make the encryption a little bit more deterministic and then things will work out. Well, you have to be really careful, because if you try to do that, you might end up breaking your encryption, which happened to me. So I had a couple of versions of Chunkyard in which I tried to be clever, and it turns out that yes, the data was encrypted, but if an attacker would know my mistake, he could just use a simple XOR and figure out the private key from my backup. Whoops. A second really cool learning experience for me was I was able, because of Chunkyard, to work on my reading list. So I guess most of you have some list of books that you would like to read. And at least on my list, there was this amazing book called Crafting Interpreters. It's really a great book about writing your own programming language and writing your own tooling to run that code. It's written in a humorous style. It's really accessible, but I started to read the book like twice or 3 times, and I always put it down. Not because it was boring, but because I had no connection to it. I had no reason to read the book, even though I wanted to. And that changed with Restic. Oh, not with Restic, with Chunkyard, sorry. Because a problem that I had, since Chunkyard is a console application, I needed a command line parser. And the C# standard library just doesn't have one. So you're always reliant on some third-party package to give you that. And one thing I wanted to achieve in the project was I wanted to get rid of all the third-party packages, at least for the main project. Let's not talk about tests here. And that meant that at one point I would need to write my own one. And that seemed dreadful at that time, because I've never done it. I had kind of like an idea where to start, but overall it seemed like a big task. And then I made a connection. Crafting interpreters is about taking, well, a big pile of text and turning it into an executable program. My task is much easier. I get tokenized string arguments and I turn them into a command. Much easier. Well, depends on the specification of your command line parser, yes, but I made the job a little bit easier for me because I trimmed down the specification. And so I could finally read the book. I learned all that was necessary, and in the end I came up with my own parser. I have to be honest with you, I only read half of the book. Because the book is structured like this. The first half teaches you how to write your own interpreter, so going from coming up with your own language and building the tooling for it, using Java. And in that implementation, you pretty much piggyback onto the JVM. So you don't need to build your own garbage collector and other things. And the second half of the book does exactly the same thing, but in a hardcore way, by doing it in C++. And in that one, you have to write everything yourself. You write your own garbage collector, and everything that a JVM gave you in the first part of the book, you now do yourself. That was interesting, but again, I didn't have a need for that. So I eventually stopped. But overall, I still call this at least a win for me. I have one more learning experience, and this one deserves its own slide. And this one is about automated testing. Now, when it comes to automated testing, and when I talk to colleagues about that, they usually everybody says that yes, automated testing is an amazing thing and everybody should do it. But I often get the feeling that it's kind of the same thing if you talk to regular people about fitness. Oh yes, that's important. Are you doing it though? More often than not, there's some kind of excuse, which may or not be valid. I'm not judging here. But in a way, these two things are kind of the same to me. Now, I had a little bit of luck because I had work experience with automated testing, and so I at least knew where to start. But the problem I had was I only focused on some parts of my code base in the previous projects. So my testing strategy always had holes. And I didn't choose them on purpose, they just happened. And I told myself that one day I will fill these gaps after I mastered the other stuff. And Chunkyard allowed me to work on them. So I started with the, again, pretty stupid idea, what if I do no manual tests? Now, I didn't achieve that, but at least this is what I was shooting for. And in that ideal use case or workflow, you do a change, you run the tests, and if they are green, you just use the tool. I have to remind you that this is my backup tool. It's the only tool I have. So using something like an automated test case or a test suite as my only means to check out what happens is kind of tough because I have, in a way, skin in the game. If I screw up my test cases and the bug slips by, I screw up my own data. And when do you find out that your data is screwed? Well, if you need it. Luckily enough, that never happened to me. I just had a, let's call it a near miss kind of situation. So I added performance improvement. I will talk about this a little bit later. And well, I ran the tests, they were green, so obviously I used the tool. And a couple of weeks in, I was just playing around with the tool, and I restored one of the files I have in my backup. It was an MP3 file from one of my favorite musicals. And when I started the music player, the weirdest thing happened. The song started in the middle. Now, I didn't know that MP3 files could do that, because usually, from my understanding, is that if you shuffle up a media file, they usually get broken. But having an audio file which starts in the middle of the song also meant that I have a pretty serious bug in my software, and that at least some parts of my backup are broken. Luckily enough, I wasn't in a crisis mode, so I could just fix the bug, redo my backup, and most important, I did what? I wrote the missing test cases. I had tests for these scenarios, but I was just missing a few edge cases I never thought about, which, well, came to bite me, basically. And over the time, Chunkyard, or the test suite around it, they started to become my happy place. So when I work on Chunkyard, either I change a feature, I just do some refactoring, or I try something, I always have the test cases to have my back. Yes, there are cases in my test suite which has holes, but I know about them, and I can do some little manual tests if I need to. But overall, I would argue that people who have never tried this have no idea what they are missing out on. Because the freedom and the security that a good test suite gives you is just something that is really incredible. Now, I just mentioned performance, so that's one more story I have for you. And it again started with a pretty easy question. How fast can I make the tool go? And the first couple versions of Chunkyard, they were just single core, single threaded workflows, right? So you give it a bunch of files, and in a loop, you take the first file, you read it, split it up into pieces, encrypt them, hash them, store them, and then you repeat the loop. At the end, you gather all the metadata, you store that as well in an encrypted way, and you're pretty much done. But that's boring. So the first thing I tried was, instead of having a simple loop which goes over all the files, maybe let's just parallelize that loop and use all cores, because that was the most naive thing I could think of. If you try that, you will quickly learn two things. The first one is you can't outsmart theory, because AMDAL or the universal scalability law, they are real, they will find you, and they will hurt you. So if you have a workflow that can be parallelized, and you start to add workers to the task, performance goes up, yes. But at some point, if you start to use more workers, then performance will decrease, because the negotiation work that they have to do between each other becomes an issue and overall causes a degradation of performance. And the second thing you learn is that you can't outsmart hardware. So Chunkyard is a I/O-heavy application, right? So if you're using something like an SSD, the SSD is pretty fine with using several requests or handling several requests at the same time in an easy way. But if you try the same thing with a hard disk, which has, is spinning and needs to find all the places you want, you again may be in a position where performance goes down, or maybe nothing happens because the disk is using all its time to just find the stuff that you want it to find instead of doing anything else. So I quickly learned that using all cores, at least in this use case, wasn't a good idea. So the easy next thing is what? You reduce the amount of cores, and in my case, I just made that a configurable number. And I knew when I want to work with my SSD, I use, maybe 4 workers, but if I engage with my hard disk, I limit this to 1. But that wasn't enough for me. So I like to watch YouTube videos, conference talks. You can find so much information out there. And because of that, I knew about projects such as Handmade Hero by a guy called Casey Muratori, or about projects like LMAX or Aaron from people like Martin Thompson. And these performance gurus pretty much always tell you the same thing. Don't use garbage collection, use simple algorithms, use simple data structures, don't use abstractions, and a bunch of other stuff. And I wanted to be as smart as those people are, or at least try myself with these techniques. So at one point, I tried an architecture using lock-free circular buffers. The details are not really important here. So I came up with this prototype. I thought that things should be faster and better, but at least for the performance tests that I did, and I never did this in a professional way, so I don't have any data I can show you, but at least for the things that I tried, I couldn't find any difference between the lock-free version and just the naive one, which uses a few cores. And this was really depressing to me. I put in all the work. I thought this would give me something, but at least for the things I tried, I couldn't find any difference. Now that might mean that my tests weren't good. It could also mean that the standard library or the tools that I used beforehand are just so clever that me trying to be cleverer just didn't work out. I have no idea. And at that point, I learned about letting go. I accepted the fact that I didn't know what I was doing, and so I reverted the change. The code is still in there, it's in the Git history, but I went back to the version that only uses a few cores. And this was the version I used for pretty much the longest time. And quite recently, I even reverted that one. And I went back to just using a single core again. I like fast software, don't get me wrong. So me doing this is puzzling, right? But what I noticed is that all my performance tests usually revolved around doing the very first backup when the repository is empty and you have a large data set. But in my usual day-to-day actions when I do my backups, the diffs between last week and this week are kilobytes to megabytes. And pretty much any of these architectures, they just finish in an instant. So while I knew that at least one of the multi-core versions, they worked pretty good, I started to wonder if I want to favor simplicity over the fancy performance. And in the end, well, I just went with simplicity. This isn't something I would do in a work environment. I would keep the fancy stuff because you need to look like a professional, right? But since it's just my project and I'm the only user, I don't need to support anybody else and I don't need to onboard other people. So me going with the single core one, that was just fine. But yes, I really appreciate fast software. And in this case, it just didn't give me anything. So all the stories I just mentioned, they were either success stories or failure stories. But for the most part, I did all of them just for fun, because I wanted to try something and I wanted to explore that topic. The interesting side effect was that even though I didn't aim for it, it made me better at my job. Yes, the performance topic was a failure, but it gave me a couple of tricks I have now to speed up programs in a pretty easy way, at least in my opinion. I also became better with my editor and my terminal. And now a few people know me as the command line guy. I have some people here who used to call me Emacs. Opa, hi there. And some of the people in the QA department, they believe that I'm a magician when I show them macros in an editor. You have to know that the current company is mostly Windows-based, so those people are afraid of the command line anyway. But that's just a plus to me. But overall, it gave me better tools to be better at my job, because for the most part, I care about automation and about pipelines. And it also made me I wouldn't call it expert, that's why I put it up in the quotes here. But now I know at least enough about encryption, even though I'm not an expert or a security professional, that I can at least be annoying in code reviews when I tell people all the things that they did wrong with the algorithm they are using. And even though I'm not an expert in automated testing, I can get you started on your own journey I know about the troubles you have or you will encounter, and I can help you guide you through that, which is something I'm trying to achieve now at my current job. And in a way, I also use Chunkyard, or at least a tiny version of that, to try to teach people about that. Because even though it's just a tiny backup application, it covers a bunch of topics that are usually hard when you do testing. There's a lot of I/O in there. You have random numbers because of the encryption. You have user prompts because you need to ask for passwords. And you have user interaction because when the tool is running, and maybe it's running for a longer time, you need to give the user feedback on what's going on in the system. And those things are usually kind of a problem when you try to put it under tests. In summary, Chunkyard, or the tooling or the language, is not really important. But I hope that at least the stories around the tool were either encouraging, inspiring, or at least entertaining, so that you can come up with your own home-cooked software or your own hobby projects, and you can find some joy in doing that. Thank you. So we have 10 more minutes for questions if somebody has them. Sure.
How do you figure out what to test?
How I figure out how to test.
What to test?
What to test. What do you mean with what to test?
If you have a big application, where do you start your, do you always start on what you think? I mean in a work environment. And you are the testing guy.
So how do I start? Well, usually, I mean, modern application nowadays, they have a lot of database interaction. So where do you start? You usually don't want to start with the database, but more with the business logic. Now, if that business logic is inside the database, you're in a little bit of a trouble, because then it's already pretty hard. But if your business logic is separated from the code base, or from the database, I mean, you can try to put that code into isolation or in a test environment in which you can control the variables in a way to test that. And usually when you start with an existing project, this is pretty hard because there's no seam. If you have like a GUI, you're at a GUI code page and it has database queries inlined there with the business queries, it's pretty hard. So the first task is always to split these up, which is again scary because you might introduce bugs. But if you don't do that, you have a hard time putting things into a test environment and you're pretty screwed. So try to split it up and try to go from there. Does that answer your question?
Pretty much, yes.
Cool, thank you.